Thank you, Mr. Mehudar. That was truly remarkable innovation and so essential. So there's no irrigation or life without clean water. I would like to invite Professor Dror Avisar, Associate Professor and Head of the Hydrochemistry Laboratory and founder of the Hydrochemistry Research Group at Tel Aviv University. Dr. Avisar has found breakthrough ways to eliminate the most toxic of chemicals from water. I invite Professor Avisar to address the audience.
Secretary General, ladies and gentlemen, I feel very honored to be here today and talk. You know that Israel converted most of the potable water for irrigation by using high-quality effluent. Effluent is a treated wastewater. And today I'm going to talk about type of contaminant that are still contains in high-quality effluent and the technology that we want to develop in order to get rid of. So, as you can see, the numbers that I'm going to present are a little bit depressed. Since 1990, however, almost 3 billion people have gained access to improve drinking water sources. There is still almost 700 billion people around the world without any solution. And at least almost 2 billion people globally use a source of drinking water that is at least fecally contaminated. That, fecal contaminated may contain pathogens that cause a lot of diseases and death. And as a result, each day nearly 1,000 children dies for a lack of water and sanitation-related disease. More than 80% of the wastewater worldwide resulting from human activity, agricultural, domestic, and industrial wastewater, freely discharged to the aquatic environment, such as rivers, streams, groundwater, and without any removal pollution, without any treatment. Moreover, this wastewater, as I just mentioned, contain much more contaminants and the familiar and the regulated compounds that we know. These contaminants can be pharmaceutical residues that I will talk today. So what are the main sources for these pharmaceutical residues in the wastewater? First is the domestic uses, household. We are consuming a lot of pharmaceutical. We are discharged from our body more than 90% of the active compounds by urine. And in a mostly developed country, it's reached to the wastewater treatment plant, more than one. In most of the other developing countries, in most of the world, it's discharged freely to the aquatic environment, contaminate river, oceans, groundwater, etc. The other sources are agricultural and the pharma industry. Today, I will focus on a certain contamination source that are really serious, the hospital wastewater. And you can see here that hospital wastewater, sometimes in developed country, may goes to the nearby wastewater treatment plant. And in other countries, in other major places around the world, most hospitals are discharged freely to the environment, contaminated rivers, streams, and the groundwater that we are drinking. So what is the problem? Well, let's try to characterize the problem in hospital wastewater. Hospital wastewater contain highly toxic, highly mutagenic, highly persistent, and highly concentrated compounds, more than any other source of pollution that I just mentioned. Sorry. I can give you an example in one of the groups. The group that we are working mostly is the chemotherapic drugs. You know, most of the hospital as the oncology ward, as a cancer building, something around 100 to 300 patients getting treated per day, discharged to the wastewater of the hospital, a huge quantity of these type of molecules. And remember that I think that I don't have to convince you that this is the highest toxic compound the human ever developed. This compound aimed to kill human cells. And they are freely discharged to the environment, to the effluent that we are irrigating agriculture. Sorry. What happened here? 1 second. Okay. Another thing, this compound, because of the characteristic that I just mentioned, can cause adverse effect to various ecosystems, organisms, vertebrates, invertebrates, humans. And surprisingly and disappointingly, 7 years ago when I started work on hospital wastewater, I found that hospital wastewater are not considered as industrial wastewater, meaning that there is no pre-treatment required, meaning that it can discharge to the local wastewater treatment plant or mostly to the local environment, aquatic environment. And we found more that the wastewater treatment plant that are reached to the hospital wastewater reached to, they are not sufficiently treated this compound. So the highest quality effluent actually contain these chemotherapeutic drugs and others while going to irrigation. So high effluent still contain these pharmaceutical compounds, therefore we need to develop a technology. So we are in the Water Institute at Tel Aviv University worked hardly to develop an in situ, inside the hospital, nearby the building, an innovative technology to break down, to remove chemotherapy drugs or others from highly contaminated wastewater. And you can imagine here, you can see here the building of oncology. We have now a pilot running for 2 years in the Tel HaShomer, the biggest hospital in Israel. So today, hospital is kind of a campus, separate building. So we can aim the treatment to certain buildings. So we can put our innovative technology that I will not going to explain you today, all this system nearby the building, diverting the wastewater and remove and break down the chemotherapeutic drugs before they're released and discharged freely to the environment. Thank you very much.